SQA National 5 Maths 2016, Paper 1, Question 11. Find the equation of a line passing through minus 2, 3, which is parallel to the line with equation y plus 4x equals 7. So parallel means same gradient. So I need the gradient and a point to work out an equation of a straight line. So let's work on the gradient first. So y equals minus 4x plus 7. So our gradient is minus 4 because it's parallel. Gradients are the same. Now we'll use y minus b equals mx minus a. And there's our point A and B. So we've got y minus 3 minus 4x minus minus 2. Okay. And then we can just work that out. Y minus 3 is minus 4x. 4 times 2 is 8, so it's minus 8. So y equals minus 4x minus 8. Add 3 is minus 5. SQA Higher Maths 2016, Paper 1, Question 2, differentiating a polynomial. So given that y equals 12x cubed plus 8 root x, find the y by the x. So we can, to get it ready to differentiate, 12x squared plus 8 root x is x to the half. So the y by the x, taking the power down to the front, 3 times 12x, take away 1 from the power, squared, plus a half times 8x, take away 1 from the power, minus a half. So the y by the x, 3 times 12 is 36, x squared, a half of 8 is 4, so plus 4x to the minus a half. And there's no reason to make that a positive power because we've just defined the y by the x, so we're done there. SQA Higher Maths 2016, Paper 1, Question 3 on sequences of recurrence relationships. A sequence is defined by un plus 1 is a third, un plus 10, and u3 is 6. Find u4. Well, part A. To find u4, we just sub in u3. So 1/3 of u3 plus 10, and u3 equals 6. So sub in 6. So that gives me a third times 6 plus 10. A third of 6 is 2. 2 plus 10 is 12. So we get 12, just like that. Part B, explain why this sequence approaches a limit as n goes to infinity. We can just say that the limit exists since, well, we're looking at the number in front of un, which is a third, and we just need to say that minus 1 is less than a third, which is less than 1, the condition for a limit to exist. And that's it for that mark. And then part C, calculate the limit. So part C, L equals B over 1 minus A. So we need to find our A's and B's. So A is the number in front of un, which is a third, and B is the number on n, which is 10. So we can just say at the side, A equals a third, B equals 10. So the limit is 10 over 1 minus a third, and this is non-calculator, so we need to do a bit of fraction work here. 1 minus a third is 2/3, so that's 10 over 2/3. To divide by a fraction is the same as times by its reciprocal. Now it's times and then flip the second one upside down, so that gives me 10 times 3/2. 10 divided by 2 is 5, 5 times 3 is 15, so my limit to this sequence is 15. And we're done there. SQA Higher Maths 2016, Paper 1, Question 4 on the circle. A and B are points 7, minus 3 and 1, 5. Let's just take a note of that. So there's A, minus 7, 3, and B is 1, 5. Find the equation of a circle. So for the equation of a circle, we need two things. We need the centre and the radius. So where's the centre? It's in the middle of these 2 points. So the midpoint of A and B, let's just call that midpoint of A and B. We add the x parts, minus 7 plus 1 over 2. We add the y parts, 3 plus 5 over 2. Minus 7 plus 1 is minus 6, divided by 2 is minus 3. And 3 plus 5 is 8, divided by 2 is 4. So we've got a midpoint. We now need our radius. So to get our radius, we use the distance formula. So we now know we've got minus 3 and 4. So the distance, let's just call this m. The distance between m and say b is Pythagoras, the square root of minus 3 minus 1 squared plus 4 minus 5 squared, all the other way round. That's the square root of minus 4 squared plus minus 1 squared. That's the square root of 16 plus 1 is 17. So the distance is 17. So now using the start of our exam paper, x minus a squared plus y minus b squared equals r squared. So our centre is minus 3, 4. So that's x plus 3 squared plus y minus 4 squared equals root 17 squared, which is just 17. And we're done there. A trig function with the chain rule. SQA Higher Maths 2016 paper 1 question 5. Integrate 8 cos 4x, add 1 dx. Cos goes to sine, check the start of exam paper. So that equals 8 sine, the whole function 4x plus 1. But then I need to differentiate 4x plus 1. Well, that's 4 and divide by that. So divided by 4. And don't forget your plus c. 8 divided by 4 is 2, so we get 2 sine 4x plus 1 plus c. And we're done there. Inverse functions, SQA Higher Maths 2016, paper 1, question 6. F and g are defined in the real set of numbers and the inverse functions both exist. Part A, if f of x is 3x plus 5, then the inverse function of x. So for part A, I can just write y equals 3x plus 5 and make x the subject. So that means that y minus 5 equals 3x. And therefore y minus 5 over 3 equals x. Don't now be tempted to write y equals x minus 5 over 3 or you'll lose a mark. Just go straight into therefore the inverse function of x equals y becomes x, so x minus 5 over 3. And we're done there. Part B of g of 2 equals 7. What is the inverse function of g of 7? Right, that sounds a bit strange, but this relies on you knowing what this means. If I put in 2 and I get 7, then that means that if I put in 7 in the inverse, that takes me back to 2. So that just means the inverse of 7 is just 2. There we go. SQA Higher Maths 2016 paper 1 question 7 on vectors. 3 vectors are expressed as follows. I'm not going to read them out, but it then says find f to h and then find f to e. So we can get a handle of what this question is asking us. If I draw a little picture, let's just call this f. I'm going up to g first. So there's g. And then it goes g to h. So let's just call that h. And then it goes e to h. Well, I could go h to e then and just go the other way around for e to h. And then we could kind of complete the picture, I suppose, by saying that there's going to be a vector there. That's going to be my f to e. I have to find that one. So that's part B, say. And I have to find f to h, which is along the middle. So that's my part A. So we know, remember, all the solid lines. So for part A, f to h is equal to, let's just trace this out to make sure we don't make any mistakes. What I get from f to h, so I just go f to g plus g to h. F to g plus g to h. Now I find writing the vectors in this form easier, so f to g is minus 2 minus 6, 3, plus g to h is 3, 9 minus 7. Adding them together, minus 2 plus 3 is 1. Minus 6 plus 9 is 3. And then 3 take away 7 is minus 4. So we get 1, 3 minus 4. Just writing that in the same format as the question. That's I plus 3j minus 4k. And we're done there. Part B, find f to e. So we want to get from here to here. We can't go that way. So we can go any way we want, remember. So we can just go that to that and then that. But we might as well just go straight across now, because we know that. And then go down. So it's f to h plus h to e. F to h plus h to e. Well, we know f to h, we just did it. 1, 3 minus 4. Plus h to e, well, it tells us e to h. So h to e is just the minus of that. So it's minus 2, minus 3, minus 1. Minus 2, minus 3, minus 1. 1 minus 2 is minus 1. 3 plus minus 3 is 0. And minus 4 plus minus 1 is minus 5. Or writing that out, minus I minus 5jk. And we're done there. Okay, SQA Higher Maths 2016 Paper 1 Question 8, the intersection of lines and circles this time. Show that the line with equation y equals 3x minus 5 is a tangent to the circle with this equation and find the coordinates of the point of contact. So if it is a tangent, it means this y is equal to the y in here. So I can substitute this into this equation. So I've got x squared plus 3x minus 5 squared plus 2x minus 4 times 3x minus 5 equals 0. So multiplying out our brackets, we get x squared plus 3 3s are 9, so 9x squared. 3 5s is 15 times 2 is 30, so minus 30x plus 25 plus 2x. 4 3s is 12, so minus 12x. 4 5s is 20, so plus 20, then minus 5 equals 0. So you're going to get a quadratic. So we've got x squared plus 9x squared is 10x squared. Minus 30x plus 2x is minus 28x. Minus 12x is minus 40x. And then we've got our number part, 25 plus 20 is 45 minus 5 is 40. And we know that that equals 0. So we can solve that by taking 10 out as a common factor to get x squared minus 4x plus 4 equals 0. And then let's solve it. Now we're looking if it's a tangent for only one solution because it only touches it at one point. So this should be equal roots. So let's check x and x. 2 2s is 4, so minus 2 equals 0. So we can say that it's got equal roots. So only one point of contact. Therefore, the line is a tangent to the circle. Find the coordinates of the point of contact. Well, we've already got this equation equal to 0, so that implies that x equals 2. And then subbing that back in to get a y, well, we might as well just use our original equation, y equals 3x minus 5. So we've got y equals 3 times 2 minus 5. 6 minus 5 is 1, so we've got 1 and 2. So our point of contact is 2, 1. And we're done there. Increasing and decreasing functions. SQA Higher Maths 2016 Paper 1 Question 9. Find the x coordinates of the stationary points on the graph with equation y equals f of x, which is x cubed plus 3x squared minus 24x, and then find the range of values for which a function is strictly increasing. Part A, stationary points, differentiation, make it equal to 0. Okay, so part A, f dash x, 3x squared, 2 3s is 6, so plus 6x minus 24. So stationary points occur when f dash x equals 0. I would always like that statement and then just make it equal to 0. Taking 3 out as a common factor, we get x squared plus 2x minus 8. So that's 3, double bracket, x and x, 4 and 2, plus 4 minus 2. So that implies that x equals 2 or x equals minus 4. Just the x coordinates, so we're done there. Okay, part B. Determine the range of values for which a function is strictly increasing. So we need to work out when it's increasing, so we're going to do a nature table and work out that. So part B, using our nature table, we're going to go along to the vicinity of minus 4, and then we're going to go along, and then we're going to do the same to 2, and then along. Notice I split this up into 2 turning points, just in case the function is not continuous here. That just saves me any bother. Okay, so that's my x. So my f dash x at this point, well, we already know that it's 0 at these two places. So pick a number before minus 4, it's minus 5. And it's always easy to substitute into the factorised form to work this out, but you can just do this in your head or do the work on a bit of paper. I'll do it in my head. So we've got minus 5 minus 2, which is negative, minus 5 plus 4, which is negative. A negative times a negative is a plus, so that's positive. After minus 4, let's just pick any number, pick 0. Minus 2 is 0, that's negative, that's positive. Negative times a positive is a negative. So we already know this one's going to be negative because it's the same idea before 2. After 2, 3. 3 minus 2 is 1. 3 plus 4 is 7. Positive times a positive is a positive. So our shape is going up the way, then along the way, then down the way. And for this side, it's going down the way, along the way, then up the way. And we have to work out when it's strictly increasing. So it's increasing when x is less than minus 4 or x is greater than 2. Okay, logarithmic graphs, SQA Higher Maths 2016, paper 1, question 10. The diagram below shows the graph of a function log 4x, base 4. The inverse function exists. On the diagram, on your answer book, sketch a graph of the inverse function. Okay, I'll just draw you a quick sketch of this. So you've got your y-axis, you've got your x-axis, and you should know that a log graph's inverse is an exponential. It reflects in the line y equals x. So these points, you can just switch the order. So 1, 0 becomes 0, 1, and 4, 1 becomes 1, 4. So I can note 0, 1 on the y-axis, and it was 4, 1, so a long 1 up 4. Let's just draw it there. And there's our 2 points, and then all you need to do is draw your curve. And you can note that that is f of inverse f of x, f of minus 1x. And we're done there. SQA Higher Maths 2016, paper 1, question 11. A and C are the points 1, 3, minus 2, 4, minus 3, 4 respectively. And it says the point B divides the AC in the ratio 1 to 2. Find the coordinates of B. So we have got 1 to 2, and that is the point B dividing it in the ratio 1 to 2. So you can imagine a little picture to help with this. Imagine I've got point A here, and I've got point C at the end, and I've got some point B here. It divides it in the ratio 1 to 2. 1 to 2. So that means that the size of BC is double the size of AB. So that means that we can say that A to B, 2 of them, equals 1 of B to C. Well, from vectors A to B, that's B minus A. That equals C minus B. Don't need that thing at the end. Expanding the brackets, we get 2B minus 2A equals C minus B. So taking the B over, we get 3B equals taking the A's over, 2A plus C. So that means that B, of course, will be a third of 2A plus C. So let's find out what 2A is. Well, we know A is 1, 3 minus 2, so we can just write 3B equals 2 times 1, 3 minus 2 plus C, which was 4 minus 3, 4. So that equals 2, 6 minus 4 plus 4 minus 3 and 4. So we've got 3B is equal to 2 plus 4 is 6. 6 minus 3 is 3. And minus 4 plus 4 is 0. So B is that vector divided by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. And 0 divided by 3 is 0. And therefore the point B is equal to 2, 1, 0. And we're done for part A. Part B says K, A to C is a vector of magnitude 1. Find the value of K. So if I know the size of A to C, then K must be the number which are times the size of that to get the answer 1. So let's work out the size of A to C. So we already know A to C we can work out A to C. So for part B, A to C is C minus A. That equals 4 minus 3, 4. Take away 1, 3 minus 2. 4 minus 1 is 3, minus 3 minus 3 is minus 6, and 4 minus minus 2 is 6. So we now know A to C. So the size of A to C is equal to Pythagoras square root of 3 squared plus minus 6 squared plus 6 squared. So that gives me 9 plus 36 plus 36, which is 7281, which means the size of A to C equals 9, because the square root of 81 is 9. And remember, k times AC was a vector of magnitude 1. That just means k must equal 1/9, because a 9 times 9 is 1. And we're done there. Completing the square, SQA Higher Maths 2016, paper 1, question 12. Functions f of g are defined on a set of real numbers by f is 2x squared minus 4x plus 5. G of x is 3 minus x. Part A, show, given that h of x is f of g of x, show that h of x equals this. So find f of g of x. So f of g of x is equal to, so f of x is 2x squared, so 2 of g of x squared minus 4 of g of x plus 5. So every time I see an x, I put a g of x in, and then I now substitute my g of x. So 2 times 3 minus x all squared minus 4 times 3 minus x plus 5. So we need to expand our 3 minus x squared. So that's 2 times 3 minus x and 3 minus x minus 4 times 3 minus x plus 5. Dealing with all of these brackets, we get 2 times, well, we've got 3 times 3 is 9, minus 3x is minus 6x, and minus times a minus is a plus, so plus x squared. Minus 4 times 3 is minus 12, minus 4 times minus x is plus 4x, and then we've got plus 5 on the end. So that gives me 18, 2 6's is 12x, plus 2x squared, minus 12 plus 4x plus 5. So that equals, we've got 2x squared, and then the x terms, minus 12x plus 4x is minus 8x, and then the number terms, 18 minus 12 is 6, plus 5 is 11. 2x squared minus 8x plus 11, yep, done. Part B, express h of x in the form px plus q squared plus r, so complete the square in other words. So part B, we've got 2x squared minus 8x plus 11. So that's going to equal, well, we take common factor between the first two terms is 2. So that gives me x squared minus 4x. And I've still got the plus 11 hanging on the end. And then we complete the square with the x squared minus 4x. So that's 2x minus 2 all squared, take away minus 2 squared, plus 11. So that equals 2x minus 2 squared. 2 2's is 4, so minus 4, and then plus 11. And then expanding the bracket, we get 2x minus 2 squared. 2 times minus 4 is minus 8, plus 11. That gives us a final answer of 2x minus 2 all squared minus 8 add 11 is plus 3. And we're done there. SQA Higher Maths 2016, paper 1, question 13. Triangle ABD is right angled at B, and it's got angles P and Q as shown in the diagram anyway, and the lengths are also shown. We have to find the exact value of cos Q minus P. So this is trigonometry addition formula. So let's split these triangles up so we can see clearly what's happening. Taking our big triangle, first of all, it's 1 then 2, which makes 3 on the side and 4 on this side, and the whole of the big angle is called Q. So there's Q. Taking the little triangle, that goes 1 and 4, and this is angle P. So since we're doing additional formula, let's check the start of exam paper. Cos q minus p is equal to cos q cos p plus sin q sin p. So I need to find my cos q, my cos p, my sin q, my sin p. So let's just do that. So sin q, well, it's a 3 squared plus 4 squared is 5 squared. You can take your time working that out, that's 5. And then you've got 1 times 1 is 1, 4 fours is 16, so that's root 17. So sin q is 3/5. Cos q is 4/5 adjacent over hypotenuse. Sin p, opposite over hypotenuse, is 1 over root 17. And cos p, adjacent over hypotenuse, 4 over root 17. So subbing all these in, root 17, sorry, into cos q minus p. That means that cos q minus p, making sure we get it all the right way around, is cos q, 4/5, times cos p, 4 over root 17, plus sin q, which is 3/5, times sin p, which is 1 over root 17. Non-calculator, so we're just playing with odds. 4 fours is 16 over 5 root 17. Plus 3 ones is 3 over 5 root 17. Well, we've got a common denominator of 5 root 17, so we can just write 5 root 17. 16 plus 3 is 19. So we've got 19 over 5 root 17. Check if anything can be simplified. So we've got 19 over 5 root 17. But simplified means a rational denominator at higher maths, so we need to times by root 17 over root 17. Don't forget that step, because there's a mark. That gives me 19 root 17 on the top over 5 times root 17 times root 17 is 17. You should be able to do 5 times 17. That is 85. So you get 19 root 17 over 85. And that is as simple as it gets. So we're done there. Evaluate numerical expressions for logs. SQA Higher Maths 2016, paper 1, question 14. Part A, evaluate log 525, 2. Because remember that means 5 squared equals 25. It's as simple as that. Part B, hence solve log 4x plus log 4x minus 6 equals log 525. So looking at our left-hand side, we combine that into one log by saying that it's x times x minus 6. So I'll do that to start with. Log 4x bracket x minus 6. And the right-hand side, log 525, well, we know that's 2, so we can just write 2. So then we can use our rules of logs to say that it's a base to the power of 2 equals the left-hand side. So in other words, 4 squared equals x times x minus 6 to eliminate the log. Now we're just going to get a quadratic. 16 equals x squared minus 6x. Moving over to the same side, you get x squared minus 6x minus 16 equals 0. So you've got a quadratic to solve. Hopefully that's factorizable. X and x. 8 and 2, minus 8 plus 2, because minus 8 plus 2 is minus 6, minus 8 times 2 is minus 16. So that gives me x equal to minus 2 or x equal to 8. But x equal to minus 2 is not a valid answer because the log of 0 or anything negative is undefined, so x has to be greater than 6. So we can just score that out and say that x has to be greater than 6 is the answer. So our final answer is x equal to 8. And we're done there. SQA Higher Maths 2016, paper 1, question 15. Identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the 0.19 to work out our k. X equals 1, y equals 9, so we get 9 equals 1 k times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3. 1 plus 5 is 6. 6 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5. Remember from our roots, 4 and minus 5. So we're done there. Part B says for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so d must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, I just write d is greater than 9, and we're done there.